So let's look at a very simple example. Toss a coin, same coin, 5 times. Okay, and we define success as observing a head. All right, then what is the random variable here? Of the 5 trials, right? How many successes are there in 5 trials? Okay. Number of successes in 5 trials. And the possible values are 0, 1, 2, 3, all the way through 6. Okay. Then, assuming this is a fair coin, the parameters that we have, n, p, and q, okay, there are only 2 parameters because q is dependent on p. Whatever p is, q is 1 minus p. So there are only 2 parameters, n and p. So n is 5. Since we are assuming that this is a fair coin, p is 0.5. So q will be 1 minus that, which is 0.5 as well. Then the possible values for x are what? 0, 1, 2, 3, 4, and 5. These are the possible values. Okay. Now the formula is right here. Okay, let me bring it down. So this part is the combination of n objects taken r at a time. So that formula represents combination, and Excel has a function for combination. So that would be COMBIN. Okay. Then we want n first, okay, the number and the number chosen. So n is that, okay, and n has to come always from there. So I'm going to make that absolute reference by pressing F4 key, comma r, okay, r is that. Okay. We want the probability for that, so r. Okay, so that's the first part. Then times p, p is here. Okay, again that p has to always come from there, so I'm going to press the F4 key, to the power, so shift 6 will give you the power. Okay, power of what? Power of the r value, times q. So we have q here. Q must be absolute referenced again, because q has to always come from there, to the power of n minus r. So we have to get n from here, absolute reference, minus r. Okay. So this is the first part. Here is p to the power of r, and this is q to the power of n minus r. So that will give you the probability. So now that we have set the cell addresses properly absoluted, okay, then you can copy. Okay, if you get an error, so that means you forgot to absolute reference these, yet one of these 3 cells. Okay. Now Excel also has a function that can directly give you the binomial probability, and that is called binomial distribution. Okay. Binomial distribution, you need to give the number for which we want the probability, so that is r. The second is trials, which is number of trials. Okay, so that's that has to be absolute referenced. And then the probability of success. So here probability of success comes from that. Again, that must be absolute referenced. And the fourth parameter is optional. Here, if you specify cumulative, then the probability that you will get is x less than or equal to the value of r. But if you want individual probabilities, okay, so if you make that 1, so that means for every x, the probability that you will get would be probability 0 through r. But we want individual probabilities, so cumulative should be set to false. So now you get the same probability, obviously. See, if I set this to 1, you'll see that you get cumulative probability as we go down, finally ending with 1 for 5. Yeah. But we want individual probabilities, so I'm going to undo that. And one last thing about binomial distribution is when you have a probability distribution like this, you should be able to compute the expected value and variance. In binomial distribution, expected value, you don't have to do x times p of x and for the expected value and then x minus e of x like what we did in the previous general discrete distribution, but there is a direct formula for binomial distribution. The expected value is always going to be equal to n times p. So n times p, so that would be our expected value, and the variance is going to be n times p times 1 minus p is q, so that one. So if you take a square root of that, that will give you the standard deviation. So that's our standard deviation.